Welcome back to another part of this cybersecurity series. Today, we're going to explore a vulnerability that is often underestimated but can silently expose sensitive data to attackers if not handled properly. I'm talking about cross-origin resource sharing, or CORS. In this video, we'll cover what CORS is, real-world examples of its abuse, hands-on labs where I exploited CORS misconfigurations, and the essential steps you can take to secure your applications. Before we dive in, let me clearly state, this video is for educational purposes only. The techniques discussed are to help you understand the risks and how to defend your systems responsibly. Never attempt any of this without explicit permission. Also, the complete write-up with all technical details and examples is available in the description. Check out the links to Medium and GitHub to follow along. Now, let's get started. Imagine you're sitting at your favorite cafe, connected to public Wi-Fi, casually checking your bank account. Meanwhile, a hidden script running on a website you're visiting is quietly trying to access your banking data. This situation highlights the dangers of CORS misconfigurations. So, what exactly is CORS? CORS is a browser security feature designed to control how web pages can request resources from different domains. When a web app wants to fetch resources from another domain, the browser first sends a CORS preflight request. The server then checks this request and, if it allows the origin, responds with the necessary headers to approve the action. The problem arises when these CORS settings are too relaxed or misconfigured. If sensitive data is exposed due to such misconfigurations, it can lead to high-severity issues, especially if user data like personal information or authentication tokens is at risk. Let's go over some of the most common CORS misconfigurations. First, overly permissive policies. If a server sets the access control allow origin header to a wildcard, meaning any domain can access its resources, and also allows credentials, it opens the door for attackers to exploit authenticated sessions. Second, improper origin validation. Some applications reflect back the origin header without truly validating it, which lets attackers spoof trusted origins. Third, trusting null origins. While null might sound like a safe default, it includes sandboxed iframes or file origins, which attackers can abuse. Now, let's look at real-world incidents. In February 2025, Mindscape XZS MySQL version 3.9.0 suffered from a permissive CORS policy, allowing attackers from untrusted domains to interact with sensitive application functions. In January 2025, a vulnerability in the Vite JavaScript framework's development server exposed sensitive data because of weak origin header checks on WebSocket connections. These incidents remind us how even small oversights in CORS policies can lead to significant breaches. Moving into the hands-on labs, I tested multiple real-world scenarios of CORS exploitation. First, in the Arbitrary Origin lab, the server blindly trusted any origin provided in the request. After logging in, I intercepted a request, added an origin header pointing to attacker.com, and forwarded it. The server responded, including the attacker origin in the access control allow origin header, confirming that it trusted arbitrary domains. Next, in the Null Origin lab, the server accepted request with a null origin. I replicated the request using curl and observed that sensitive user data was returned, proving the misconfiguration. Then, we explored prefix match issues. Here, the application trusted any domain starting with its own domain name. By setting the origin header to hacktify.in.attacker.com, the server accepted the request, exposing data to an attacker-controlled subdomain. In the suffix match lab, the application trusted domains ending with its own suffix. Using a crafted origin like evilhacktify.in, I successfully bypassed the check and accessed sensitive data. We also had the escape.lab. The server failed to correctly handle dots in its validation patterns. By crafting an origin like www.hacktify.in, I managed to bypass restrictions and retrieve data. Then, the substring match lab showed how the application trusted any domain containing the trusted name anywhere in its origin. Setting the origin header to hacktify.co was enough to fool the server. Finally, in the arbitrary subdomain lab, I demonstrated how trusting any subdomain can backfire. Using some subdomain.hacktify.in as the origin, the server granted access, confirming the vulnerability. Through all these labs, one thing becomes clear: poorly configured CORS policies can expose sensitive user data and actions to external, untrusted websites. Now, let's talk about defense. First, always validate the origin header properly on the server side. Never reflect it back without verification. Second, avoid using wildcards in the access control allow origin header when handling sensitive data. Third, explicitly specify trusted origins, and keep this list as narrow as possible. Fourth, restrict HTTP methods and headers in cross-origin requests. Only allow what's absolutely necessary. Fifth, set the access control allow credentials header to true only when required, and never use it alongside a wildcard origin. Sixth, handle preflight requests properly. Only respond with the exact methods and headers that your application genuinely needs. Seventh, include CORS headers in all server responses, even in error messages, to maintain consistent behavior and avoid accidental information leaks. 8. Regularly audit your CORS configurations using browser developer tools or security testing tools to catch misconfigurations early. Lastly, educate your development team. Understanding CORS and its risks will ensure these mistakes are avoided right from the start. By following these best practices, you can strengthen your application defense against CORS attacks and ensure your users' data stays protected. For the full technical breakdown and code samples, check the description below for the Medium article and GitHub repository. Once again, remember this is for educational purposes only. Use this knowledge to build safer, stronger applications and protect your users. In my previous videos, we've covered HTML injection, XSS, IDOA, SQL injection, and CSRF. If you've ever encountered CORS vulnerabilities in your projects, or if you have any questions about what we covered today, drop them in the comments. I'd love to hear from you. Thank you for watching. Stay curious, stay secure, and I'll see you in the next tutorial.